Good evening, teams. Today, welcome you. I'm welcoming you all with the first session on IPG Carmaker of the BAJA SAEINDIA 2026 webinar series. Today, we have Mr. Rohit with us, who is one of the engineer supporting with the technical things in the IPG itself. And yeah, today he is going to explain you a brief introduction on Carmaker, like how the Carmaker will work and how the interface is. So let's welcome Mr. Rohit over here. Rohit, over to you. Yeah.
Thank you, Rhythm. Good evening, teams. Welcome to the first session. Myself, Rohit, and I'm a solution engineer at IPG India. I'm going to give a walkthrough about IPG Carmaker. The first thing, we are just having the complete overview of the Carmaker. So the first chapter is what is Carmaker. Let us go through how Carmaker works, what exactly a Carmaker. So Carmaker is a solution for your virtual test driving. So basically, when you are prototyping or when you're modeling a car or building a car, you need to do many things like modeling the things, checking with the ECUs, maybe rapid prototyping. Also, you need this. All things will take time when you do it in physically. So in the way, CarMaker helps the developers or the engineers to rapid prototyping or testing the different scenarios, connecting to the real-time hardwares, also third-party tools. Almost like we can run the CarMaker over AWS clouds, maybe a Docker and Azure. So this is what about CarMaker. So CarMaker is a physical engine, physics engine. It will mirror the real vehicle in computer model. So CarMaker offers a closed loop simulation where we can include the road and roads infrastructure like the bumps or the wake buildings. So next is like traffic and environment. So in the CarMaker, you can add the traffics. You can create a different type of scenarios where your virtual test vehicle will behave as a real vehicle, which is running on the test tracks. So in the virtual prototype, vehicle will run inside this continuous loop, interacting with the IPG roads, traffic environment, also the driver. We can add the sensor models. So all this helps us to develop the ADAS features. Also, in the IPG car maker, the IPG driver will behave as a real driver, where he can do all the actions like pedal pressing, gear changing, steering rotation. All those depends on the IPG driver parameters. So let us go with the general structure, the virtual vehicle environment. So as I have earlierly told, the virtual vehicle is nothing but computer model representation of your actual vehicle. So this vehicle behavior exactly matches like a real vehicle. So in the car maker, we have modeled all the vehicle parts like the engine, tires, suspension, steerings, and other parts. So in the IPG car maker, you can create a road which is very similar to the real road, like road frictions and different conditions. So we have a virtual driver that we call it as IPG driver. He will interact with the virtual vehicle by controlling its parameters. So let us go with the second part called car maker interface toolbox. So now we have seen what is virtual vehicle environment. Now to monitor, now to use all these things, we need something called as a toolbox, like which will hold all those things. So you can use CarMaker interface toolbox. So it is called as GUI. In this, you have all the options to create a project folder, select a vehicle, and the vehicle parameters. You can use the test series or test manager. You can lively monitor the simulation. You can plot the graphs. So all these tools are integrated in this GUI. I can just show you a quick demo of how GUI looks and how to interact with the GUI. So this is my Carmaker 14.1.1 GUI. So here you have option called create a project. You will create your project and you can select already created projects. So to select a test run, you need to click on files, then open, select your test run. So also using this GUI, you can open IPG movie NX, also IPG control. You can model your vehicle using the option called parameters car. So you can see all these options here. Also, we have one option called graphics, where if you click on this, you can clearly see the what is the car maker coordinate systems for all the bodies or reference and the trim load. So let me run a test run. So in IPG movie and movie NX are nothing but both are the visualization tools. Using all people next more about different turns, different. So to control the driver behavior, we use something called as manure, where we define each action of the drivers, where he has to stop or how many seconds he has to drive the vehicle and to apply the brake and the different conditions. So let's begin with chapter 2, monitoring the simulation. So, as I have showed you, you are running the Carmaker simulation where you can have the different options. In the IPG movie or movie NX, you can add the different environment or different backgrounds to the here for the simulation. Also, you can use some other options like camera settings. You can use default settings or the different bird eyes views or the different views like sitting inside the vehicle. Also, you can change the environmental settings. So this is about IPG movie. So IPG movie NX is nothing but it's a high rendering software or the visualization tool. So where you can see the IPG, the vehicle simulation in more enhanced quality. So here also we have same options like uh, you can add multiple windows to visualize the simulation like this. So you can add some show markers or different options are there. So you can add the different camera settings. So if you change the settings, you can observe the different type of views here. To learn more about IPG Movie NX, you can click on the help, you'll get a Movie NX user manual and you can refer to it. So let me show about how to use the IPG control. So while simulation is running, it will show something called C1 or the C2, the Carmaker instance, which is active with its name. So if you click on here, you can add the data sources. It's nothing but from the which Carmaker instance you are getting the data. Also, the post-processed simulation data, you can add it here or the IPC control, and you can plot the different parameters like the brake parameters and car speeds. So using the Carmaker interface tool, GUI, you can do all those things. Also, you can control the simulation speeds like 2x into RT is nothing but the Carmaker will run 2 into like 2 times of speed. It is like 1 milliseconds into 2. So you can start and stop the simulation here. So also few settings are there where you can add auto start IPG movie whenever you open the IPG Carmaker GI. NX or IPG movie will start in the background. Also you can add IPG control. So how the this is all about monitoring the simulation through online. So if you want to visualize this data very detailedly, you can click on fit totally. So all this data will be fitted like this. You can align the graphs. So here we have something called cursor setting. If you click on the analysis cursor, if you click on any of these points, you can see the data. Also, you can control over the mouse, like uh, you can zoom in, zoom out. So if you click on particular point, you'll be able to see complete signal data. Like you can see the first one is the uh, car.a of z and C1 is brake.pedal and car.a of x. So all are in different colors. So all these quantities are nothing but car maker user accessible quantities or user variables, which all have the meaning. You can check all those things in the our reference manual. To access any of the car maker guides, you need to click on the help in the main GUI. You'll be able to find all of our documents. We have written everything in very detailed manner. So let's get into the chapter 4, test run. What is test run? So test run is nothing but the closed environment or fully closed loop simulation environment. The necessary elements like the road, IPG driver and its manual conditions, traffic and environment, the scenario and the road, vehicle and vehicle loads, tires and trailer, all are integrated and all these are saved as a one file called as a test run. So for a virtual test drive, all those we need the same parameters or the same components we use in a real time, like on the road. Like so, we need a driver, we need the test track, we need the vehicle, and we need all the environment condition, vehicle loads. So all these parameters are individually stored in a project directory you, as a test run file. So this is the structure of Carmaker project directory. The bin which will contains the real-time executable, or it just contains the GUIs for IPG movie, IPG and all other components. So next we have subfolder called data. So where we have all the basic details like chassis, configurations, mix or open scenario, all these files are created under the data folder. So in the chassis, we have databases of your vehicle model. So configuration, we have the kinematics of axle, and MISC, we have the ECU parameters, SIM parameters, and the output quantities. All these are stored in folder called maze. Next is the open scenario. So Carmaker supports the importing of third-party tools like third-party scenarios, where the open scenario is also one of the one of the one of the company which they will make some scenarios like based on different type of roads and different parameters. So this also will support IPG Carmaker support. So next, the pick. In this folder, you can store some images of your vehicle, the preview pictures. In the road file, the whatever the road you created in scenario window, it will be stored as .rd5 files. Also, next is the script. If you have written some automation scripts for the test manager, all these are stored in the folder called script. And the sensor, when you add some sensors to the vehicle, all those sensor parameters are stored in the sensor folder and the test run folder. So it will stores all the virtual test drive files. So if you open a test run file, you can see which vehicle is been selected, what are the some vehicle parameters or its loads and all you can see it. So next, all these tires have the whatever the tire data is generated, it will be stored in the folder called tire. Next, we have the trailer folder. Inside the trailer folder, all those trailer parameters are stored. So next is the vehicle folder. Inside the vehicle folder, all of your vehicle parameters are stored, maybe chassis and other stuffs. So next is the document folder where we can place some project specific documents inside it. So we have one more folder called include and libraries. So these two folders are mostly related to the coding part. So it will store some external libraries. Also in the movie and movie NX folder, whatever the objects you are visualizing in the IPG movie, those all are the 3D models. So those models data and those models are stored in this movie and movie NX folder. The plugins is nothing but the FMUs, the functional markup units and other models you can store it in a plugins folder. And sim output is used for giving some inputs to the car maker while starting the simulation. So those files are called input from the files. Next is the sim output folder, where all the results stored in that folder, all the log files are stored in that folder. Also, we have SRC and SRC for Simulink folder. Both are used for different purposes. So SRC is more related to the C coding and writing your own code and modify or register some models to user.c files. So SRC for Simulink, this is the dedicated folder where we have all the libraries. You can interact with the IPG car maker via MATLAB. You can model your own vehicle or the tire models, engine models. So all these are stored in here. So we'll create one folder called CM projects. Inside this, you have your project folder. As I have told, this is the bin. Right now it is empty. So if you go to the data, if you select a vehicle, we have all the datas. So if you go to the test run and open this file, you can see in very detailed way which car is used and which version of the car maker it is, what is about the road, and how many links is there, what is the roadside, what are the bumps are used. So also your vehicle parameters. So what is the template used for the driver, and the routes, how many routes are there, what is that route object ID, and some driver parameters, driver conditions are there, also environment conditions are there. So all these are mentioned here, and with respected files will be fetched from the data folder when you are running the simulation. So thank you so much, guys. If you have any doubts, you can ask me.
Um, yes, Rohit, thank you so much for delivering a brief introduction on the car maker. Uh, Teams, it is requested for you all to put your queries on the chat. Once the session is completed, we will answer all your queries. Yeah. Currently, as explained briefly by the Rohit, there is a there is a project folder in which all the details of the car maker project is been recorded. So, I hope you all have referred the IPG car maker guidelines, and yeah, we have a specific nomenclature for the Baha teams to submit the project folder on a website. Yeah. Um, so considering the same, let's check how the project folder is to be created for Baha submissions. Okay. I hope I'm audible clearly. Anyone can um, check whether my screen is visible or not. Hello.
Yes, Rhythm, you are visible.
Yeah. Okay. Fine. Once you have installed a car maker, you are supposed to create a project folder by going to the file. Sorry, yeah, by going to the files, you have to create a project folder by create a new project folder. Select your, yeah, it is suggested to select a default dictionary that is CM projects, under which you have to rename your project folder with team ID underscore team name. That is, uh, that is your team ID. Suppose 261001 or 262002 and so on. Similarly, you have to mention your team name as well. Once you are done with the project creation, press OK, and you will get a project folder inside your CM projects, which will resemble like this. This project folder will include subfolders such as bean, control temporary data, documents, includes library, movie, annex, etc. Once you are done with the project creation, you need to ensure that the data containing in this project folders is much important, and this will be the one which will be used to configure your car maker. Now, suppose uh, now going with the car maker, like you have to first create your car, that is your Baha model, into this virtual environment. Similarly, there are options for scenarios and maneuvers. Once you create a car, you were supposed to build a road. Yeah, you were supposed to build a product example. We have lots of product example over here. Considering a various project folders, you can select any one of them, and then you have to run your vehicle over at least one or two project folders just for the ensurety that the vehicle is working smoothly. To create a car, at very first, we are having various subsections of the vehicle, such as assembly, body, suspension, etc. Everything resembles a car subsystems. Now, for going through with the project folders, here we have chassis, configure, driver, miscellaneous, pics, roads, etc. While creating while creating a car file, you will be encountered with many of the files attached in this session. So, suppose we are having a tire that you have created a custom made tire. We are going to demonstrate you how to create a custom tire in a upcoming session. Yeah, but once if you are creating a tire or suppose a suspension file, suppose a suspension kinematics file, you have created a parameterized file named with SKC, then you have to mention it in the chassis section. That is a chassis, and here you have to mention as team ID underscore team name underscore chassis. Similarly, in that you have to mention whether this is for the front or rear. If you have created a SKC file and uploaded in this folder, then you have to select it in the section over here by selecting a file from the model. Okay. But once it is done, just ensure a proper linkage of each of the files. This is an example for kinematics file. Similarly, there is a chance of having a movie folder files or a pictorial view. That is your car image. Okay, that is you need to mention under team ID team name folder. Similarly, we have an entire description over here. That is under the data folder in the chassis, you have to create a folder named team ID underscore team name underscore chassis. Yeah, in that you have to create a front or rear SKC file. Ensure this is not a compulsory file, but once you are going with the kinematics, IPG kinematics, then you have to mention the SKC file into this. Similarly, your vehicle once created, a entire car being created, it should be mentioned with the nomenclature we mentioned as over here. That is team ID underscore team name dot car. Here, this resembles a vehicle file. Ensure you don't name it similar to small car or other things, dot temporary or any other files. Okay. Coming to the next, that is a test run, where in the upcoming session you will get to know what the test run is and how to create a test run. A brief introduction I'm providing you over here. That is under the file in the new, you have to create a test run, or you can simply open one of the project folder, uh, and example is there. So let's suppose I've gone with the rights and here is the bumps. I have opened one of the product example, and then within this I will go select my car from my projects and then will run it over here. Okay. Coming to the next, that is tire. Tire For the tire also you need to ensure that you follow up the nomenclatures, that is team ID underscore team name underscore tire. This resembles your uniqueness in the tire file and so on. The objects, the file that is a object file that resembles your vehicle image should also be named similarly. For the road, that is a maneuver and ATP. We are not going to continue with these things, that is a ATP and maneuver, but we are going to provide you a new product example in the upcoming validation event guidelines. Yeah. Um, and in the movie section, you need to mention your object file. And in case if you are going with the Simulink model, that is you are incorporating a Simulink model, then you must ensure that the Simulink folder is there and the proper naming of the Simulink file is also maintained. Yeah. So this is how a brief introduction has been given on project folder creation for your vehicle model. Ensure you follow this for the proper submission of your vehicle. Uh, yeah, thank you. Now coming on how to create a car file. Uh, we are having Sudarshan over here. Sudarshan, over to you. Please explain on how to create a file and subsequent parameters. Yeah.
Yeah, bro. Thank you. Hi, guys. Okay. Today we are going to see about the parameterization of the car for the BAJA India vehicle. Okay. In this webinar session, I will be explaining about the vehicle dataset generator, assemblies, and the body section. First, I will explain with the PPT I have prepared. Then I will show it in the software side by side. These are the basic important things you should follow while building your or entering the data for your buggy in the IPG Carmaker. Like the teams are allowed to use the Simulink and any softwares for the subsystems. Then you can go through the quick start guides. Then the most important is the driver weight, which is 75 kg. You should every two teams should use this driver weight. Okay. Then just follow these important things while entering the data for your buggy. Next, in the vehicle set generator, the vehicle set data is generated for the basic reference of the. Okay, 1 minute. Okay, the parameters we will go into the car, and in the file section you can see generate car data. Okay, in this we can enter the basic data of the vehicle, which like we should choose small car as the such data are mentioned in the guidelines. You should select the small car, and the vehicle parameters should be entered as per your vehicle you have designed, like unloaded weight, vehicle length, vehicle width, height, wheelbase, track width, front of rear, and the rear overhang. Also, the tire data can be entered here, and you can later the tire data can be generated here also. Coming on to the advanced settings, the vehicle must be defined as the rigid or flexible mentioned in the rule book, and the drive axle you have chosen. Some may be coming in all-wheel drive or rear-wheel drive. Okay, based on your drive, then your gearbox option you should select which one you are using. For the steering, you should mention your turning circle and the maximum steering angle you have occurred while you are calculating in your steering module. Okay. Then for engine, the nominal power, RPM, max torque and speed should be mentioned. For the Embaga teams, you can mention your nominal power of the motor, RPM of motor, and max torque of your motors. For the transmission, to calculate the values and the enter here. You can leave the suspension anatomy as default. Okay. Then if you give generate, the data we have entered and the vehicle length wheelbase will be coming here. If you give yes, the generated data will be shown in the description of the configuration area where the blank is the wheelbase, the track width, the weight of the vehicle, and the tire data will be generated here. After this, going on to the engine mount,
Yeah, sorry for the disturbance. Sudarshan, are you back?
yeah, bro.
Yeah, okay. Let's start. Just hold on. Okay, sorry. Yeah.
Yeah, where I left off. After generating data, the if you then the engine mount. So with this engine mount, we can define the engine position in the design. Then coming for the body, here we can leave it as it is. For the chassis, these are the positions of your component where the wheel FR means front left, FR means front right. Similarly, rear left and rear right. Carriers are the uh, wheel assembly, so you can mention the weight of the wheel assembly. And then for the position of the wheels, you have mentioned in the design, you can measure it with the coordinate system. Yeah, the FR1 coordinate system you should assign in your design. From that FR1 coordinate system, you should take a dimension for the XYZ components and you should enter it here. Moving on to powertrain, engine data, gearbox data are for Embaga teams. You should choose FRD, which is a default. For, you are entering the coordinate system with that. Okay. Then while coming for the EBAGA section, team should select electrical motor and the gearbox positions from the design. Then you should enter the as you have mentioned and constrain the coordinate system before in the FR1 position. From that position, you should take the engine motor coordinates, electric engine and motor coordinates, then for gearbox coordinates. Okay, you should select FR1A, which is a default you have selected in the coordinate system. Then coming for the trim loads, the driver weight should be mentioned as 75 kg as per the mentioned in the rule book. For other trim loads like you can mention your other components like uh, electrical subsystems and other subsystems. So it could right, um, so it could the values support your vehicle model and can run properly. For the sensor mountings, as yep, the parameters of the road sensor will be in the B10 section of the sensors in the guidelines. In the upcoming session, they will explain about the sensor creations. Okay, the sensor you created in that sensor section will be available here. You can click plus, then your sensor name will be shown. Then you can select your sensor and add it your sensor in the vehicle. Next, moving on to body structure. You should choose a rigid or flexible body based on your vehicle data. If you if you choose the rigid body, you can enter the position of your bodies. If you are choosing flexible, you have to unpick this because our vehicle will not come under this criteria. Okay. Then in this flexible, you can add your stiffness and amplification of your suspension and dampings and amplification. With this, you can iterate and conclude with the best values you are running while you are running the vehicle if you are choosing flexible. Coming on to outer shell, we should create the OBJ file for the vehicle. We are using in that. Okay, the assembly you have modeled your vehicle. If you go any softwares like SolidWorks, or there will be a section called system options. In that, you can go and see the option export. In that, you can save all the components as a one assembly and export as a OBJ file or MTL file. With that, you can download any software like free 3D generation softwares. In that, you should paste and import your vehicle model. Then you should render the objects like the shapes you should use in that generation is polygons and triangles. Okay. So be sure that the nodes are less than 50,000. After creating the OBJ file, save it as a OBJ file and take a top and side view of your vehicle because we have to enter the top view and side view of the vehicle in the picture section where you have to mention a team ID and then you have to mention your save your top view and side view of the vehicle with the team ID, team name. Then you can choose it, then click OK so that your side view and top view will be shown here. For the OBJ, you should paste your file in the movie section as per Rhythm explained before, where you can view your OBJ file and you should select it. If you give OK, it will get loaded. As coming for the aerodynamic section, you can leave it as it is. These are the data and things you have to do while generating your basic assembly data, car data and body. Thank you, team. Thank you, guys. You can take over.
Uh, Thank you, Darshan, for your wonderful session. So I hope like majority of the area has been covered regarding the submission part of thing. Okay. Is my screen visible? Hello. Hello.
It's visible, bro.
Yeah. Okay. Thank you. So hi teams, I'm here to explain you the powertrain part, which is one of the crucial parts. So coming to further, I'll be dealing with the H-Baha and M-Baha powertrain. So first in this, for the electrical teams, it will be decided by the rhythm. He will very give you a brief out. So coming for H-Baha powertrain and M-Baha powertrain, we are going for the conventional thing. And in that, we are going to first for the engines. So engine, there is a data called inertia, engine off speed, engine idle speed, and this complete data will be given from our side, Baha only. So the engine off speed is basically when the RPM hits below this thing, the engine gets stopped. And Indian idle speed is also like where the engine nominally runs on that, so the engine is on. And the torque ignition off will be the torque generated while the engine goes running. So crankshaft duration is depends upon the team, which is not given from our side. So whether your x-axis, the output shaft, the crank output shaft will be where your CVT is, one of the pulleys will be connecting. That will be in x-axis, y-axis, z-axis. That depends on the teams and designs. So this has to be done by your team. Now coming to the torque, there are three different two types: drag and full throttle, and another is 2D speed and gas. So basically, we have to use only speed and the gas throttle. Here, this data is also given in the rule book as for the H-bar teams. There is given here. So in the guidelines, completely they have given the data also in the bit layering. So this is for the fuel consumption and this is the engine torque. So basically, this is the data where at what RPM, how much throttle is being open, and what's the torque you are getting from the engine. So this data is also given by the supplier of the engine, and the amplification shouldn't be further one. It should be mandatorily kept as one. Coming to fuel consumption, at what RPM throttle, how much is your engine is getting consumption your fuel. So there is a graph plotted over here at what RPMs the fuel is going to be done and what rate it is going to be exhausting. So here the amplification also will be one here. The capacity here in the four last things, it is your fuel capacity is nothing but your tank capacity. For the H-Baha teams, it is 5 liter CNG tank, so it will be a 4.5, and For Baja teams, it is will be some around six, I guess. So which is also be mentioned in the guidelines. Just go through the guidelines and please don't play with these values. You have to strict adhere to these values only. The initial filling, we are going to fill the 90% for H Baja teams and M Baja also. The fuel density is what fuel for the H. This is hydrogen based, so it will be of blend. So it is 0.128, and the heat value of the fuel. And we are not going, as our engines are naturally aspirated, there is no turbocharge and also intake manifold. So we are going to turn off this. Please don't turn on these things. And coming to the bodies, as mentioned in the rule book, we have to be adhered to the vehicle engine weights, which will be mentioned in the rule book as well as the guidelines too. Please follow up this. And coming to inertias, it is very crucial parts in all the cases, as Ridham and everyone have said. So inertias plays a key role where your performance is based on these things. So these things you may get from the CAD models as well. So your orientation part also affects in this inertias also. Now coming to starter motor, just don't keep as a one-day lookup table, as we don't have that much data, and starter motor value is not defined, so keep it as default. And for Mbaha teams, in case the starter motor values doesn't start for your 0.48, then you can change this mechanical power to 2 kilowatts. Rest of the things, please keep them as default only. As we don't have any starter inventor, so we are not going to on this thing at all. Uh, Coming to clutch, there is an inertia in and out, which is also defined from our teams. This is given by Baha, and position piston connection and position disconnect. This is also given by us. And the maximum torque is this is as a formula in the rule book in the given the engine's maximum into your lower ratio of the CVT. So that's value of here comes it is, as you can see here. In the guidelines also they have specified this thing. The clutch model should be selected as friction here as a continuous variable transfer. In this case, the maximum torque is like 22.7 for H Baha teams. It is 22.7. So for M Baha, it will be having their maximum torque. So that into your CVT's lower ratio is the value of your minimum torque. And also the bitly links will be here for your engine data, as in gas, throttle data, fuel consumption. Please copy paste these all those things. And your friction slope is 12. It is to be strictly adhered. Torsional spring value can be differed from the team to team. Is the value of your spring inside your CVT. So as from your calculations part, you can add your values. You can also add a characteristic value or one day lookup table. Coming to gearbox, as many teams use CVT, so there is a continuous variable transmission, and there is no limitation that we have to use this only. You can use your manual gearbox. If you are using manual gearbox, you are going to for manual. If you are using a CVT, then you are going for the C transmission. In the gears, we have ratios. So your CVT ratios are here. The maximum and minimum ratios will be entered here. And every team must have the built-up time as 2 seconds. Because of the belt and frictional losses, we are going to have a CVT of built-up time will be at 2 seconds. And this thing is the ratios which your gears has been. So how many number of ratios will like approximately a CVT will have? Suppose if we are having a 5 ratios, then how are they going to distribute it? And if you have the data of how at what torque, speed and RPM torque losses will be there, you can enter and you can have a play with these things also. So each ratios there will be a different. So according to that you can fill them. Coming to the gearbox, same the mass will be your gearbox original values, which will be also deflected in the assembly part over here. And the inertias you can get from your CAD models. Suppose if you're using a CAD software, there will be in like KTR or anything, you can get the inertia values from there itself. Coming to the tank, there is nothing much. The value of your fuel tank will be here. Here we are considering the fuel tank which has to be completely filled. The mass of fuel tank is considered with the fuel, not only the empty fuel tank. So okay, make sure that you are filling with complete fuel tank. Approximately, if you are having a for the HBAR teams, it is a 10 kgs cylinder without any fuel. If you are having the fuel, it will be around 15 kgs. So the value will be the 15 here. Please don't enter the empty tank value. And same inertia you can get from your CAD models and the CAD software itself. Please make sure that inertias are entered carefully because this plays a vital role in your performance as well. Coming to driveline, some of the teams have, for the MBAHA teams, it is four-wheel drive. So they can have four-wheel drive. For eBAHA and HBAHA, there is a rear-wheel drive and four-wheel drive. So depends on your drive team, you can select it. Please keep your external torque off. There is no nothing torque we are giving for the tires. It is only coming from your gearbox to tires. So external torque is not there. And if you are choosing and four-wheel drive and rear-wheel drive, then you have a flexible drive. That depends on your teams. And here comes inertia in and out. This part is that this inertia is from your engine output, so I mean like CVT to gearbox input, and inertia out is that from your gearbox output to shafts. And the inertia case is the frictional thing. And how much is your transmission for, suppose if you're having gear ratios of 7, 10, 9, 11, 13. So that is your transmission gear ratios. One of the gear ratio will be entering here. And efficiency, there is, please don't keep one. What is your efficiency, like 96% or 98%? So based on that, it will be like 0.8 or 0.98 something. So a part of your efficiency, the percentage you are getting is we have to enter over here. So how much efficiently your transmission is going on. So power supply for M-Baha teams and H-Baha teams won't be there. For the E-Baha teams, it will be there, and Rhythm will be adding all these points, covering it there for the E-Baha part and part. Coming to control unit, for the M and E Baha teams, please keep the mode as genetic. There is no electrical mode or series modes. And we are here the gas interpretation is on, which means the how much throttle you are giving and what is the torque you wanted to get your gas inside your engine. So basically, it is like opening of the valve by the pedal. So you can have a kick start, like a button start or a key start, that is completely on yourself. And there is nothing much to play with this thing. Please don't change any of these parameters. So this data has also been given in the rule book, sorry, the guidelines part. So here it is gas pedal throttle. So how much throttle you are going to give and what is the torque you are going to get out. So basically it is the opening position with the throttle respective. So these things, the maximum throttle is like if you give a full throttle, how much torque you may get. This is 250. And what is the zero torque is -7. So this data is also been provided by the the Baha side. You have to enter as per the sheets only. Please don't change this value. It may lead you to the penalties. Coming to electrical, the maximum throttle value, ideal speed PI, and also this torque control P values shouldn't be changed. It should be kept one. These are the internal engine component values. So this is also been provided from the Baha side. Please don't tamper this any of the components. And here is your TCU, traction control unit. So basically it is for the CVT or the gearbox inputs, something you can say. So there are a number of things how you can define. You can define it. It is an automatical or converter, or if you have a CVT, then you are using CVT. If you are using a dual clutch transmission, you can add that. So based on your transmission unit, you can add this thing. For instance, we are using a CVT, and if this is a speed envelope or a single track, if you know what your revolution rotational speed minimum is, you can enter that. For the H bar team, it is a 1200 as a minimum engine ideal RPM, so it is 1200. If you know how a single track works, you can directly go for that and speed envelope. So how much throttle you are opening, at what velocity it will go, and what is the rotational speed inside of your crankshaft. These are the details which you are going to enter. If you know properly, then you can have this thing and you can use a speed envelope. That is completely on your team's choice if you wanted to use speed envelope or the single track. That's on your choice. There is no restrictions on this. You can use it. As for M Baha and H Baha, there won't be any motor control unit and also the battery control unit. So please leave them as default. Don't change your MCU to not specified. Please leave this as a basic only. That's it from the part of thing. If the anything if you wanted to know, you can just have it. But for the M-Baha teams, there is another thing. The starter motor is not there. They are going to have a full crank thing. So there you have to please you don't have to change any of these values. Okay. So for H-Baha, there are some values which has to be changed here. But for M-Baha, please don't change any of these things. That's it from my side. Thank you guys.
Yep. Thank you. Thank you, Sandeep, for explaining a brief intro on the powertrain of HPAHA as well as a little bit of MBAHA. I guess each team will consider this and follow all the guidelines which we have provided to them. Yeah, coming to the e-BAHA powertrain. For the e-BAHA powertrain, just hold on, let me share my screen once. Yeah, coming to the e-BAHA powertrain, we will go with a flow like Carmaker parameters in that a car file over here powertrain. Here, teams should make a selection that is a electric as a compulsion. All e-BAHA teams should select this as a electrical. If the team is having two motors, three motors, or vice versa, one motor, anyone can be choose as per their actual vehicle configurations. Then after, if the team is selecting a the single electric motor configuration, we will be having the option of one electric front wheel or rear wheel axle. Generally, the teams use rear wheel axle or a front wheel axle as well. The selecting your current source of driving. Then after, you need to go with the drive source. Once you are at the drive source, ensure that you make the gearbox selection first. That is a automated manual transmission, or a no gearbox. If if your motor is directly coupled to a gearbox, then you should be selecting a no gearbox option over here. And then after, the gearbox parameters should be delivered in the drive line over here. Coming to the drive source, that is your electric motor. We have to define your electric motor parameters. That is the inertia, ratios, build-up time, etc. If you are not having a data over here, keep it as a default. The definitions for this things you can refer from the Carmaker user guide as referenced in the IPG Carmaker guidelines. If you will check with the Carmaker, everything is been explained detailedly over here. Suppose you want to check with the definitions for torque. You have to go in the Carmaker over here in the GUI section under the help. You will get a reference manual as well as user guide. I have already loaded a user guide over here. So in the user guide, we have a detailed subsections for each of your reference. In the powertrain section, you can go to the overview, drive source, drive line, and all. Read this user guide thoroughly for each definitions you are encountering. Don't assume anything while entering a data. For the torque, you can go with the characteristic value, that is ideal minimum and maximum torques, or a lookup value. If you are having a characteristics value plotted against a RPM versus torque graph, then you must be entering the same. The amplification you can alter at the time of iterations. Ensure no amplification should be greater than or less than 1. Sorry. Yeah. While making a submission, the amplification value should be exactly 1. And the efficiency of the vehicle model. The efficiency cannot be 100%, that is valued as 1. It should be mentioned as per your motor characteristics. The body of an electric motor is to be configured based on your motor size and their mass. The weight of the motor should be mentioned over here, as well as based on the position and orientation of the vehicle, the electric motor configurations inertia value should be there. uh, you can refer the FR1 coordinate systems mentioned in the user guide for calculating the inertias. Similarly, in case if you are going with the regeneration part, consider the inverter, else you can leave it as default. Coming next to the driveline. For the driveline, if you have selected a no gearbox over here, then then the same should be reflected over here, whether the front wheel drive or a rear wheel drive is here. Suppose your rear wheel drive configuration is there, then the rear wheel transmission should be configured. Here in the transmission section, you should be entering your gear ratio if it is a constant. Suppose you are having a 13 is to 1 or 10 is to 1 or 12 is to 1. Whatever the ratio of your gearbox is, you need to mention it in the transmission section, and so on the efficiency. Coming to the next part, that is a power supply. The power supply basically means your battery and the accumulator packaging. Now, if the team is going with the DC-DC converter, then the then the then the converter value should be mentioned. Else, if the team is going with the LV system, then the value should not be considered over here. Team should ensure they are using low voltage plus high voltage as a configuration for your vehicle. Then after, for the LV batteries, in case if you are having an LV battery mounted in your vehicle, then the capacity, ideal voltage, initial state of charge, maximum, minimum, everything should be mentioned as per your vehicle models. To refer this, you can go to the IPG user guide. In this, there is a option of drive source. In this, you can take a complete overview on the drive lines. Okay. Coming next to the LV battery, HV battery, that is your high voltage battery. The capacity, ideal voltage, whatever you are going to, like for 72 volts or a 48 volts, that should be mentioned over here as per the guide, IPG Carmaker guidelines. Ensure you follow the IPG Carmaker guidelines thoroughly for the parameterization. Coming next to the Coming next to the state of charge influence. Ensure you take this state of charge uh, and you plot a factor against your state of charge. The maximum power should be limited to the 9. There should not be any deviation in this value, and so on. The mass and the inertia values of your HV battery as well as the LV battery should be mentioned as per your characteristics. Suppose your HV battery is mentioned of 35 kilowatts, then it should be mentioned over here. Similarly, the inertia values based on your orientation with respect to FR1 coordinate system should be calculated with your CAD model and mentioned in the file. Coming next to the controls. For for controlling a electric vehicle, the electric option should be selected, and then after the gas. The gas represents a maximum as well as the minimum throttle value. This represents a zero value for the zero throttle and the maximum torque which you are obtaining at the initial stage of the motor is need to be mentioned. So on, the battery management need to be kept off, and the regeneration should be based on your configuration. If the team you are going with regeneration part, then the same should be marked as checked, and the upcoming values need to be mentioned. That is as SOC limit, SOC range, and speed limits. These values should be based upon your regeneration capabilities. Coming next to the traction control unit. Over here, just ensure whatever you choose in this model, that is, if a no gearbox or a automatic or any of the other model you are selecting should be similar to the one you are using in the traction control unit. Okay, if you are going with no gearbox, select as not specified. Coming next to the motor control unit. The motor control unit should be a basic model, and the PI values need to be mentioned. That is a proportional and integral values. Coming next to the battery control unit. The battery control unit should be low voltage plus high voltage as per the as per the guidelines. Yeah. Thank you. Put all your queries related to the powertrain as well in the chat. We will answer you shortly. Coming next to the subsystem of steering and suspensions. Uh, so we are having a Sandeep over here, Siddhant as well. Siddhant will handle the next part, that is steering part. Thank you.
Hello, am I audible?
Yeah, bro.
Yes, Siddhant.
Sandeep, you can stop sharing the screen. I will share the screen from my side. No issues.
Okay.
Hope so my screen is visible. Is my screen visible?
No, Siddharth.
Just give me 1 minute. Is my screen visible now?
Not yet, bro.
No, Siddharth, not yet.
Is my screen visible now?
No.
No. Is it visible?
No worries, Siddharth. I'll present the PPT. You can just
Okay.
start seeing.
Okay. Okay. So, firstly, starting with the topics that are going to be get covered in this suspension and steering. Basically, we are going to see how we are going to configure the suspension and steering part in the IPG car maker. So for that, I would just like to let you know that before starting, everyone should go through first with the user guide and the reference manual that is provided from the IPG, because that will be the main sources where all our concepts will be cleared for the suspension and steering, what exactly that parameter means and how to input that value. So move on to the third slide. Sandeep, your screen is not visible. Can you just reshare your screen?
Okay, yeah, just a second. Is it visible now?
It's not visible from my side, but no issues. Just moving on to the third slide. So basically, in the kinematics of suspension and steering, the thing is that most of the teams get confused in what things to be entered and what not to enter, and how to get the best suspension settings for the IPG car model. Move on to the fourth slide. So firstly, we need to enter the control units in the suspension. So for that, the teams who are the upcoming teams who have just entered into the IPG and don't have what exactly to do, for them, they can just go to the default settings. Teams can leave it as default. Basically, what is control units? Control units are nothing but they are the force elements where where we can input the individual active suspension system, like what all forces are there acting on the vehicle. We can input that. Uh, those are the control units. Moving on to the force system. Am I audible?
Yes, Siddhant, you are audible.
Yes. So
Go on. Yeah.
moving on to the force system. Force systems are the part of the control unit. When we enter a control unit, we need to put the force system to. Like the force system is nothing but it is an user-defined suspension force system. Like there are different models in suspension system for like there are spring, parasitic effect, damper, buffer, bushings. All those are some of the components in the suspension. And if we select for the force system and we choose to build in an independent suspension for in IPG, we need to go into the force system. For in detail force system, you need to refer the user guide and do the configuration according to that. Moving to the next, that is the springs. For the springs, there are some fixed parameters that you need to select. That first of all, for the springs, the stiffness attribute should be for sure Hookian spring. Should be defined for the front and rear axle. No changes to be done over there. For the stiffness mode, there can be a characteristics value. Teams can enter the 1D lookup table. Those who want to give uh, those who want to input the parameter according to the wheel travel and provide the forces if they have those parameters with them. If not, they can just simply enter the stiffness value along with that the amplification. Now, most of the teams get confused in between what is exactly an amplification. Amplification is nothing but the multiplying factors, and it depends upon the iterative process. Like you need to carry out the iteration, and team must ensure that the amplification value should be 1. Like no changes to be done in the amplification. It should be by default been kept as 1. And in the spring, firstly we need to select Hookean spring. There are two options. Either you can go with the 1D lookup table or you can go for the stiffness and enter directly the stiffness value. Moving on to the parasitic effect. This can be used to calculate a parasitic stiffness force representing the suspension bushing torsion between along the bushing rotational axis while wheel travel. So parasitic effect is nothing but the effect when a vehicle is in motion. It generates a velocity and a stiffness. Like when the damper moves in a to and fro motion, there is an effect produced, that is a parasitic effect. If teams have those data with them, they can put in those data and parameterize those data. If the team don't have that data, then you need to set it as 1. And if the team doesn't have the necessary data, you need to input the amplification as 0. For in detail, you can just refer to the user guide and check it once if you can get those parameters. Moving on to the damper model that need to be selected can be the Newtonian damper or the Newtonian damper plus top mount as per the design. Whatever design you have chosen for your vehicle in real life, those parameters need to be inputted over there. According to that, you need to select the parameter. Now, what should be the damping mode? The damping mode is same as that of the spring. If you know the values, you go for the 1D lookup table and put those values according to the velocity and the forces and create one graph which is similar to what you have done in the designing while designing your car in the real model and provide those details. If you don't have those things, just go with the static value and input the damping value, push and pull value. That's all. And As in the spring, you need to ensure that the amplification is set as 1, no changes to be done over there, because amplification is a multiplying factor. It will multiply those values that you have inputted over there. So keep it as 1. Moving on to the buffer is the same. It is one of the part of the suspension from like spring and dampers. Buffer is also one of the part, but it is restricting the wheel travel while spring is compressed and extended to a certain length. So this model, if the teams have the data with them, they can input this data, or else if they don't have any data of the buffer, they can just leave it as default. Moving on to the stabilizers, most of the teams, I don't think so, they are going for a stabilizer. Like stabilizer is nothing but a roll bar, where it can be used in the front or the rear suspension. If the teams are designing their vehicle as per the suspension roll bar or anti-roll bar, then the teams can go for the stabilizer. If they have those datas with them, then the team should ensure that it is set to 1 and the parameters should be given in that way. And if the teams don't have stabilizer in the suspension system in real model, then they have to set the amplification as 0.0. No changes to be done over there. Now let's move to the kinematics. This is one of the trickiest part where most of the teams find difficulty how to model a vehicle, what all things to be done, because while doing a test run, most of the teams face issues in the to and fro motion of the suspension and vehicle don't stay on the patch. So for that, what teams can do, move into the linear kinematics model, slide number 12. So for in that, first team needs to go into the kinematics, and there they need to select if the teams are the new teams and they don't know how to get those coordinates from their vehicle model, from the CAD model, and how to input those. Simply the teams can just go into the kinematics front part and select linear 2DF. And over there in the user guide or in the guidelines, it's been mentioned this diagram. Just go in there. You must have calculated this value while designing the suspension in your real life car model. Just input those values. So basically, the static value will be for sure 0, 0. There will be no changes. The main changes will be there in the compression value, for in the compression and in the steer values. So when you will be doing your modeling or when you will be carrying out the designing of the suspension, you must have used some softwares to get those data, and you must have got those PDF files. From that, you can directly input those over here, or else you can use the linear kinematics of the IPG Carmaker too. For in detail, you can go through the user guide, how to get those values, how to calculate those, and everything is mentioned over there. Moving on to the non-linear kinematic models, most of the teams try to get into the non-linear kinematic models, like by creating the SKC or the MBS files. If teams have not used an external software, for that you can go for the non-linear kinematic models. In that, you can simply make an SKC or MBS file. From there, you can get the coordinates and put that file and generate the kinematics over there itself. For that in detail, you should refer the reference manual thoroughly, because reference manual will help you out for how to set the origin and how to get those coordinates. Because in the SKC and MBS file, the most important thing is to select the coordinates or the axis, that is the origin axis, in a proper way. If we don't select that axis or the origin, from the 0, 0, the points that we are getting, the coordinates that we are getting will not be aligned, and the suspension behavior that you are expecting will not be in the proper way, and the teams will be facing more difficulties while creating those SKC and MBS file. So for that, go thoroughly through the reference manual and the user guide. This last thing is the steering. Okay. So for the steering, firstly, there will be a steering gear ratio. For the steering gear ratio, teams can use multiple options. For firstly, it will be the characteristic value. If teams don't know what all parameters to be input, simply they can choose the characteristic value. Characteristic value is nothing but the radian per meter. Like basically, it's a ratio defined by constant coefficient of steering wheel angle. Basically, the steering wheel angle ratio to the steering track travel. So teams must be having those data with them while will while they will be doing the steering calculation. At that time, they must have got these values. They can simply input those values in the characteristic value. Most of the teams face troubles in those things like the steering ratio, like the characteristic value is not at that point, and they don't get the output of that steering behavior. So for that, they need to check through the calculation once again and do the iterations and get that value in that way. If teams have the different coefficient of steering wheel angle to the steering rack travel, they can go for the lookup table 1D ratio. In that, they can input the value of the radian per meter according to their convenience. And over there, they can put in a table where they will get an pinion angle to the ratio. So for in that, they need to just give a stair step at what stair step they are getting what ratio. After that, the vehicle performance for sure will be more easier and more smooth in maneuvering. After that, there is lookup table, that is 1D rack travel. Basically, it's the same part. There will be a absolute rack displacement for the various steering wheel angle. Team can also obtain that option if they wish to. So for the steering also, you can go through once to the user guide and check it in detail. How can you just configure the steering and suspension in a proper way and get the advantages of those parameters or the features that are there in the IPG to get the best result out while maneuvering. Uh, that's all from my side for the suspension and steering.
Yeah. Thank you, Siddhant, for briefing us out on the suspension and steerings. I hope teams have configured their suspensions and steering models in the Carmaker. Teams, I would like to open a chat for you to address to post all your queries. One by one, we will start answering you. Uh, so Sandeep, you want to take a first question? Like,
Yeah, yeah.
yeah. Go ahead. Like, we can start with the first one.
Do we have to create folders for any data that we are not using or data that we don't have with us?
Hmm. So for teams, if you are not having a data, that is a specific file which you are not using for your car maker. Suppose example, you are not having a specified tire file and you are using a default tire, then you don't have to create a project folder with the subfolder with a tire file. Okay, you can leave it as a blank. Uh, Coming to the next. How
Uh,
Mhm. Yeah, go ahead,
can you
Sandeep.
explain what are the subsystems we can simulate in MATLAB and how to input them in IPG?
Um, yeah, uh, yeah, for the MATLAB, you can select. Hello, sorry, am I audible?
Yeah, you're audible.
Yeah, okay. For the MATLAB, you have to go to the CarMaker, select a folder called CM from called CarMakers as well, while creating a project folder. Then after, yeah, you have to open your MATLAB and then configure your environment as well. Sandeep, you can post a tutorial link in the chat as well, correct now? Okay.
Yeah, for the tutorial of what? This
For the tutorial of CarMaker, like how to
Okay,
integrate
okay, got it. I'll just
it
post
with the
the tutorial
Simulink.
videos of whatever is there. I'll just post them.
Yeah. Um, Rohit, you want to say something?
Yeah, actually, while they're building a project folder, they have to just select SRC of source build or environment. So it will create SRC files and they can import that file inside the MATLAB, then there is one script, cm They have to run that script in the terminal. So then there is something called generic model. From there, they can start creating their own models, maybe break or other models. Yeah, that's it from my end.
Yeah, thank you. Yeah, thank you, Rohit. Hope the teams have cleared that out. Um, yeah, coming to the next one. Yeah, engine torque curve for MBAHA team hasn't been specified. How to get the you will be getting a Carmaker guidelines for the MBAHA as well. In that you will be getting a link soon. Uh,
Just a
we
second.
have
There is a
requested for
question.
yeah.
Okay, there's a licensing issue with the team. So Shubham, kindly reach out to me or Ridham. We can sort this thing out. Okay. And how, sir, how to recognize the errors? So for recognizing the error, you have an error message thing. So from there you can show. I just a second. I'll show how exactly that looks. For an instant, if I am going to change this thing, uh, okay, let's change a gearbox over here from like not no gearbox. Okay, or like okay, and I just kept here closed, and I just start here. Like for an instant, I have started this thing. So here is an session log where you can see whatever errors you are getting here. So warnings are something which can like if there are issues, but it is okay. The vehicle going to run, but it's so this error is something that is like your vehicle is not running at all. And also you can see that your vehicle is not running over here. Also the status is also like ideal or anything. That means you are having an error, but you are not sorted thing. So the red things, everything you are having a session log, you can get everything. So from whatever error you have from the menu or part or anything, in this session log, you are gonna clear that thing. Okay. Sir, in vehicle dataset generation, should we keep select automatic in gearbox as well or using gearbox as we are using CVT?
For the CVT, we are having a continuous variable transmission option in the Carmaker itself. Please check out with the same and yeah, you can configure with the help of that. This will be addressed by the organizing committee. Yeah.
There is another, sir, in the car weight put earlier while generating the data, we need to put only the weight of the roll gauge and everything else in the trim load.
Your additional license request will be processed, and if not, please reach out to us with the same. Sir, what if my node are more than 50,000 for OBJ? How should I reduce that? While creating a OBJ file with any of the CAD models, you will be having a option for number of modes. You need to reduce the counts of triangles or the nodes, whichever option you are having in your CAD model. By that, you will be able to reduce the node numbers.
I just want to specify that for the OPG, there is nothing, no bonus marks or anything. It is just for an outer aesthetic look. That's it. You can also, if in case your nodes are more high after compressing your OBJ file, you can also edit them in the notepad file. In IPG, S, W at some sections, there are add modal options. So what this stands for?
Better. Yeah, user
Vipul,
defined.
can you post exactly briefing your question, your query? Indian talk for MBAHA has haven't been specified how to get those. See for the for MBAHA, don't worries. The data will be coming to you in the guidelines. So in that you will get your torque data, your engine and fuel consumption data also. So from that thing, you will get extracted and you can just use in your car maker. Okay,
Um, uh,
I think
Seems Rohit
Rohit
wants
has
to add
already
something.
Yeah, yeah.
Actually, I think the question add model, I have answered it.
Yeah, yeah.
Basically, in the vehicle data set, those are related to C code. Or if you have any other options like FMU or created some model using MATLAB, you can select the model over there. So if you have any specific doubts, please reach us. I have mentioned my email ID there. They can reach us. Yeah,
Thank
that's
you,
it
Rohit.
from my side.
Okay. For eBaha teams, we are using a transfer case. What should I put for TCU? Can Shunki Shunki, can you please explain us briefly like what you mean by transfer case? I'm getting error in while running the file as embedded, not found. Okay. For geo road files, you can check with your vehicle uh, powertrain systems. There must be some error with the powertrain. Like if the initial torque is 0, then the NAN error would be there.
So basically that comes in your powertrain hero. Just let me show you where exactly you will face those things. So where you may see that your vehicle gets toppled or everything. So that's what happens here. So there are two areas as I have mentioned. Here is your transmission efficiency, and also there is an other efficiency in the gearbox area. So all these ratios and these things come together, combine, and then you have something. So the powertrain which may exit over here in the general thing, or like over and like areas are somewhere. So you have to give precisely your efficiency over there. Then only your vehicle will be running smoothly. In case if you are going excessing of then your vehicle may get rollover, or your vehicle may not start. For HVAC teams, there are starter motor issues while you will see that vehicle is not starting or positioning error. So for that, I have already mentioned in the starter motor, you change the value of initial at the 2 kilowatt, then your vehicle is going to run smoothly. Could you please summarize which all values we cannot change and which all values are to be left as default? See, Kevin, as there will be in the guidelines, you have we have mentioned there which has to be followed and which are left to be defaulted. And other values which are there, you can also alternate with them, and you can change on your perspective and your vehicle ergonomics and dynamics things. So for open differential in front, what should we put for front axle
Mm.
for that thing?
Okay. For the front axle, you start initiating with the differential model. If you are having a query, just connect with your alumni coordinator, and they will help you out with the same. Okay.
So
Could you please
basically
summarize?
that for that is actually where your differential ratios will be. So the gearbox ratio will be different, and the differential the front which splits the right and left. So it has a certain transmission efficiency and also the ratio. You have to mention that thing. And for front axle, there is an option. There is like we don't have any option called for the open. You can use a locked or like viscoelastic. Could
Um,
you please summarize
uh,
which always cannot be changed and which always are left? Okay, Phoenix, it has been already answered. When is the virtual dynamic track will be released for submission of the test run? Soon it will be released in the guidelines of the validation event. So from that part, you can also have the test runs and everything.
okay.
Okay, Kevin is asking for
So how
e-Baha
to generate
powertrain.
SK6? Okay, for the e-Baha powertrain, we have detailedly summarized that in the Carmaker guidelines. Let me show you once again. Over the year, in the Carmaker guidelines, each each one has been summarized in a detailed way. Suppose if you are having a issue with the control unit, you have to make sure the uh, selection is as per the electric model. In case if you were supposed to put it as a default, then it will be mentioned as leave them as default. Okay, so refer it thoroughly so you can get it with the accurate parameters. Um, for for the SKC file, yeah, we are going to conduct a session soon on how to generate a SKC file. That is with the help of Carmaker, IPG Carmaker का kinematics file version. Okay.
Not
Uh,
compulsory for MBAR teams, right? IPG.
Khush, can you explain like what you are referring for the compulsion part in Ambaha? Yeah.
Is it your participation in this event or lot? Like what is exactly your briefing? Just specify that. Then, so in the car weight put earlier while generating, see basically in the car generation weight, you are gonna add your another like a complete rule is another components like your fire extinguisher part or the body panels, mountings, guards. From all that values, you are gonna add that. After that, in that the wheel carrier like your hubs, your wheel assemblies, and engine, gearbox, fuel tank, that will be added in the sub departments. A part of that, other every components will be added in the generation part only. Sir, our team is not using a stabilizer bar, so I can keep the value as a default, but while I am trying to simulate, it's showing the error on the stabilizer value, how to rectify that. So for this, as Rhythm has already said that we are going to have a brief session on the IPG kinematics. So there then it will be answered. Is it compulsory for e-Baha teams? Sri Govind, whatever you wanted to explain, just can you brief it out again? There is for e-Baha in the driveline section, what other parameters apart from transmission do we have to put in? Can you elaborate after the inertia in and inertia out values for e-Baha? In the drivetrain section, what other parameters apart of transmission do we have to put in? Can you elaborate about the inertia in and out values? Rhythm? Hello.
Yeah. For the e-Baha powertrain, other parameters apart from transmission do we have to put in? Um, if yeah, apart from the transmission ratio, you can input the drive in and drive out values. Other things you can leave default if you are having a gearbox directly coupled to the motor. Okay.
Yeah. So even I want the license because two licenses were not working. As per the manual, there are no such options for CVT in the electric vehicle. After loading the OBJ file, the vehicle is not being placed as it should be. The orientation and size is not proper. So how can you fix it? So see Isha, for the OBJ file, you can fix it using the something in the notepad. You can change the values and orientation with the X, Y, Z axes. So your vehicle will be small, big, and at your required size, you can just adjust with that. And coming for as per manual, there is no such option for CVT in electric vehicle. Rhythm wanted to take this question.
Yeah. For the CVT of electric vehicle now, you can start by entering very low values low steps in the gearbox option. Like just hold on, I will share my screen once. Mhm. Hello.
Yeah,
Is it
Rhythm, you're
visible?
audible.
Yeah.
Yeah, yes.
Okay. Okay. So For the powertrain of electric section now, you are having a continuous variable option as well. But in case if you are not working well, you can use this automatic manual transmission. And then after you start putting low values of gear ratio, like a point 1, point 2, point 3, and then go on. And that will help you with parameterizing this CVT. Okay. Reach out to us if you still having any queries. Yeah. Sir, how many free IPG license are available per team? For this year, we have restricted till three number of licenses. In case if you are having a query, please write us to us on Baha Communication.
Can you explain the drivetrain for e-Baha powertrain about rear axle? See, for any Baha, E or H or M, the drivetrain, the rear axle part is the simple thing. It is common for everyone. I hope, Sri Govind, it is, I have explained it, and also Rhythm has explained it again. I hope your query is being cleared. Vipul, in
Okay.
IPG S, W, at some sections were add modal options. So what it stands for? Rohit, would you like to answer for this?
Yeah, Rohit, would you like to answer this?
Yes, just a second, I'll answer.
Yeah, sure.
Actually, wherever you see add a model option in vehicle dataset, so either you have to write a C code. If you click on add a model, can anybody share the screen? Maybe Rhythm or
Yeah, I will. I will.
Already I have did that.
okay, can you go to vehicle dataset parameter?
Yeah, just a second.
Okay.
So here there is something option called not in the sensors. Can you go to powertrain or okay, you can go to brake model.
Yeah,
Brake, brake. Not here. Yeah, powertrain or brake.
it's powertrain.
So yeah, if you want to add a model, click on that. Yeah, please click on that.
On
So
this.
yeah, if you created any C code model, you can get it here. Like you need to just mention its name and it will be imported here. Or else there is one option called create. No, can you click on that? There is small option there, right?
Okay.
This one.
In front of create. In front of create, there is a tick model is there, right? Tick option is there in front of create. Just mention some name for the brake model and write a name. You can use my model for both the section.
Okay.
If you click on OK, so it will generate a template. Okay. Here you need to mention all the calculation parts. Then this model has to be registered in our user.c file and then executable has to generate. Then only this model will work. Using user.c, we can create custom executable where we can integrate our models or different calculations. So that's what it means. I hope this query is addressed and the person who asked, he got his answer.
Yes. Yep. Thank you, Rohit.
Thank you.
Is recording of
Uh,
this session available?
it will be shared soon.
How MATLAB can be used for other than brake model?
Uh, MATLAB can be used to configure your powertrain modules. If you are using a CVT or a manual gearbox with the electric configurations, then you can configure your vehicle in the MATLAB and import it to in the Carmaker. Yeah, many other options are available. You can run through the Carmaker with the help of MATLAB and check out for the scene.
Yeah, Rohit, you can just add some whatever you want to.
Yeah. Using the MATLAB, there is two options. One is you can create your custom executable that you will work in SRC folder, and there is one more folder called SRC for Simulink. That means it's used for co-simulation. Co-simulation is nothing but using the MATLAB, you will be running whole car maker. Also, some videos regarding there on IPG training, user training, you can get it in YouTube.
Okay, thank you, Rohit, for
So,
your.
yeah,
In the aerodynamics section, you can put it as default, or you can even turn that off. Yeah.
Yeah, if you have done the CFD and you are thorough with your values, you can also add them as if you wanted. So what about our presentation? Is it in the PPT format or poster format? Aarti, this time we are not having any presentation round over here. We are only having a validation event. So you have to give your test runs and submit your project folder. In the body structure parameterization, do we have to put the mass of a sprung mass, and does it position refers to the position of the combined center of gravity with respect to FR1?
Sudarshan, would you like to answer? Sudarshan is here. Okay.
No, the question, the voice was breaking.
Okay.
Okay.
What's the question?
Uh,
Sandeep, you go ahead.
yeah. In the body structure parameterization, do we have to put the mass of sprung mass, and does it position refers to the position of the combined center of gravity with respect to FR1? Hello, am I audible?
Ah, yeah, bro, yeah, bro. Okay, ah, yeah, yeah, this F41 is combined with the CG, bro. The portion of the CG is combined. So the sprung mass, bro, it's in body, right? I have to see this software. Sandeep, bro.
Yeah, just a second. I'm just showing you the screen.
Ah,
Is the
yeah.
screen visible?
Ah, yeah, bro. It's
So like
in bodies.
basically, in the chassis part, this the wheel carriers will come under what categories you have defined. You're gonna give the values of all the wheel carriers. If you are a four-wheel drive, you have differentials for the carriers and the front wheels. You're going to define here. As you can see, these all points are reference to all these things. So how exactly see this is the front wheel. So we have the weight of here and also the positions. You can change it as per your dimensions and the CAD modeling thing. And the overall body mass, this is the here comes the unsprung mass. Okay, sorry, here comes, yes, the unsprung mass below your suspension down parts. So this all are the unsprung mass, and here the structural, the weight is a part other than what I have already mentioned. So the
Oh,
carriers, tank, gearbox, everything a part of that, whatever like mounts and everything will be added in this in this weight.
it is also referred with the FR1 we have entered in the coordinate system.
Yes, yes.
Yeah.
All these are referred through this point only. Is IPG is not mandatory for MBAHA.
IPG is mandatory for all event sections, that is for E, M, and H as well. You have to submit this vehicle model for participation in validation event at the physical round.
Will you be
Okay.
giving us the final tracks or do we have to make it ourselves? See, the test run tracks, we are going to provide you that. You don't have to make your own tracks. You have to test your vehicle on that tracks. So can you please tell us about validation event, what we have to do in it? So Aditya, in the validation event, what happens is, so when you create an IPG model and submit to us, so we have a simulator, a car simulator at your physical event site. So your vehicle parameters, the project folder we will be opening over there, and we will give you a test, the track where you have to drive virtually the vehicle, which the track will be representing the physical track, the dynamic track which is there on the event site. So basically, you are going to drive yourself the car in the track in the event site.
Okay.
Like I think it's optional for MBAHA. No, there is no option. This event is mandatory for all the formats EBAHA, MBAHA, HBAHA, and also ABAHA. Will we get the recordings of this meeting? We will share you. So can you please tell us about validation event? What we have to do it? Aditya, I guess I have answered it right now. When is the deadline for submission of IPG?
Uh,
So the
it will. Yes, Sandeep, go ahead.
so the deadlines for the IPG submission will be released in the validation event guideline. So please adhere to the deadlines and submit on the time. In EBAHA powertrain, power supply can be explained the magnitude of values that we have to input as auxiliary low voltage and high voltage consumption.
We have to input as auxiliary. Uh, for power supply, can you explain the magnitude of values that we have to input as auxiliary LV? Okay, fine. For that, for configuring your parameters with LV system, right? You have to just you have to go in the LV section, powertrain system over here. I guess my screen is visible. Uh,
Yes, yes, Nigam.
Hello. Yeah.
Yes, yes.
In the power, yeah, in the power supply, in the sections of general, you have to mention the capacity of your LV as well as the capacity of your HV system. Whatever the maximum capacity, like suppose in ampere hours, say 150, 180, or whatever as per your vehicle model and constraint to the rule book, you have to enter it accordingly. Ideal voltage. Ideal voltage is the voltage which represents your vehicle, your battery capacity as a voltage. That is to be around 48 or 72 as per your configurations. And initial state of charge could be 100, and minimum state of charge should never be 100, but it should be up to 20%. Like from okay, and the maximum state of charge could be 100 as well. Okay. This resistance and capacitance are the specific cell values that you can refer with the help of reference manual. For reference manual, you can go with the help in that you will go to the reference manual. In the reference manual, under the under the powertrain system, you will get all the things uh, in drive source. Uh, I'm not getting it currently, but yeah, it is there under the drive source. Uh, Hold on, let me check where it was. Yeah, under the power supply in the battery. Okay. in the battery, you will get the definitions of like how the values are to be calculated uh, for this resistance and capacitance. Um, this subsystem is derived by the Chan model. Okay, yeah, thank you. Coming next, we are using Fox float pneumatic dampers. Yeah, for the Fox float pneumatic dampers, you will be having a reference manual if provided by the OEM or the vendor. You can refer that for your parametric values and plot a graph in the 1D lookup table. For my email ID, I have put it my number, and you can reach out to us via forum, or you can connect with us via alumni coordinator, or put me on a WhatsApp for the same. Yeah. So can you please tell us about validation event? I think the validation event explanation has been provided by Sandeep. But yeah, a brief explanation again. Validation event will compare your vehicle model virtually and physically. The difference between the time gap in the physical track as well as the virtual track maneuvered by you will be considered for scoring. One is the
For the deadline, I have already mentioned, you will get that in the guidelines. For also for rebaha in motor parameterization, for the ratio, do we have to put input value of a primary drive, etc.? Example, a chain drive connecting gearbox and motor.
do we have to input values of a primary drive, example a chain drive connecting a gearbox and motor? Okay. In case if the gearbox is directly coupled via a primary drive or something, you can you can calculate a overall gear ratio, that is multiplying ratio at the end to the start, and put it directly to the transmission system. Yeah, there are no restrictions on the coding part of the vehicle parameters. Yeah, you can use any anything feasible for you.
For e-Baha, considering all and all-wheel drive, how do we parameterize the center differential?
For the central differential, the we need to check based on your vehicle systems. So please explain it briefly over here, or reach out to me personally on the provided number.
E-Baha powertrain power supply can be explained the magnitude of values that we have input. I think this has been answered with rhythm previously.
Yeah.
Sir, are IPG
Then
results required to be included in the design event document submissions? See, team, this is up to you that you wanted to include or not. There is no restrictions that, like, we are not saying that you can't add or anything. That is up to you that if you wanted to add in that or not, that completely depends on the team's individual perspective.
so for front axle, what should I put for open differential, as there is not an option in IPG? And what exactly is buffer, and how do we enter the value in IPG? Buffer buffer. Do you refer by the kinematic section in buffer? Sunning Reddy. If yes, please explain it briefly, like how you want it to be.
Yeah.
Okay.
So in our buggy, we are using an H arm in lower and single arm as upper. In the rear axle, what suspension model should we select in IPG kinematics?
Mm.
Rohit, as this thing will be covered in the IPG kinematic session, but still, if you wanted to know, there are training sessions which I have dropped in the chat box. You can once go through it with the last few trainings. We have already mentioned here. Okay. And if you want still more further about this, tomorrow, like the next session will be on IPG kinematics. On there, you can get very brief on suspension parts and relate it to them, like SKC and whatever you wanted to know. When you define FR engine and put powertrain components coordinates with respect to FR engine in car parameters in graphic section, it shows that my gearbox is below the car. But if I put it as per FR1, it shows correctly in the graphic section. It is inside the car. But my CG increases way more than required. Sudarshan, would you like to answer on this?
So I don't know the reason why the CG is increased, but they have mentioned uh, they are using the FR1 currently with the engine coordinates, but I don't know the reason why the CG is increased more than required. I
Okay.
think
Once.
if they can give the dialog box,
Okay.
then we can see through it.
Yeah, there might be a chance like in FR engine coordinate system, you must be calculating your reference with the FR1. So just ensure like the values you are inputting with the help of CAD model is respected with the engine coordinate system while calculating it. If it is done correctly, then the CG will reflect correct as per the
Yes.
actual
In
values.
case if you wanted to know more further about this, once go to your CAD model and put a point or the point like a dot over there, and from that you measure every distances to the engine, and then you put that values in your FR engine. So then your vehicle's CG will be also stable and the references also.
Bro, can I tell one thing?
Yeah, yeah.
Teams, if you are getting any errors while putting the FR with respect to FR1, you can create FR1 coordinate system in your assembly model with respect with the overhang and the graphic model provided in the IPG. Then with that coordinate system you have created in the assembly in the rear side of the vehicle, with that perspective, take all the values so it will be more accurate so that you don't get any errors while entering data.
Mm. Can you answer this considering we use a DC-DC converter? Okay, in case of DC-DC converter, you don't need to enter any values for the LV system. You can leave it blank and just input the values against the DC-DC converter as mentioned. Okay. I hope this is clear. Sir, we calculated with reference to FR1 in SolidWorks only, yet it still showing an error. Uh, if it is still showing up an error, we need a bit more explanations on your calculations. So please reach out to us via Alumni Coordinator.
Kindly share the screenshot of the error they are showing in your system.
Which is more preferable, MTL file or OBJ file of the vehicle so that we can directly import the vehicle. See, MTL or the OBJ both are same. There is not much difference. Then you can directly import them using other third-party applications like which is mentioned in the rule book, the guidelines also. So with the mesh labs, you can do that thing and you can import your vehicle. For the colors also, how to import the color also has been mentioned in the guidelines. Once you can go through it to add colors to your OBJ also. Considering we have a locked central differential, what should be the torque ratio front and can we elaborate the mounting model? and other inertia values.
Mm, I think we need to connect on your configurations of your actual vehicle. Please reach out to us in detail for the same.
Yes, and Rajendra Reddy. And there is an inaccurate with the wheelbase and CG. CG section parameterization compatibility to put in a SKG file. What do we need for that? So for this thing, just kindly wait for the IPG kinematic session. After then, still you face the same issues, then please reach out to us. I or Rhythm, anyone like Sudarshan, Siddharth, reach out to us via your alumni or you can directly ping us. We'll be there to answer you.
Okay. Addition to that, if you are checking your info section over here in in the assembly section, in the configuration, if you are selecting it, checking your descriptions instead of info, then please ensure that this will be the accurate values of your vehicle which is being considered. The overall mass, overall gravity, this you need to refer because once you create a vehicle with the help of generator, the description will automatically load it. But upon changing all the parameters, this description will not be changed, but infographics will be changed. So please refer to this. Uh, okay, just to clear it, so FR1 is the rearest. Um, Hello, am I audible?
Yeah, bro. Yeah, bro.
Okay, fine. So for FR1 is the rearest most point projection on the road. So so far, Baha vehicle it will be the rear wheel and point projection. Correct, correct. It should be at the rearmost point. If your vehicle is running ahead of your rear tires, then it should be reflect. It should be having your rear tire and point as a FR1 coordinate system. Okay, the
The
vehicle
vehicle
geometry
geometry
created.
creation in the SolidWorks should contain the suspension to be free or locked while importing in IPG.
Um,
This is for
while
OBG, right?
while OBG is totally for visual purpose. It does not reflect any of your parameters representing a car model. So it should not be the dynamic model while creating a vehicle. But yeah, there is no constraints on the same. You can use any of the vehicle model from the SolidWorks.
Is it necessary to use the
It
SKC file? So, Kevin, there is no like particularly you have to use this file only in this session. There is like you can use linear to DF, linear to DF1. That is your perspective. The SKC file will give you a more accurate projection of your suspension compared to other than that, other with the linear to DF and one. So what do we put for buffer in car parameter section?
for the buffer you need to make your amplitude zero in just hold on. Okay, for the buffer, if in case if you are not having a buffer in your suspension geometry, then you make your amplification value as zero and leave all the default values as it is. Make the amplification as zero so that it will not calculate any of the values for front as well as rear. Okay.
I just wanted to add some points to the rhythm. So basically, buffer is something. What exactly this term refers is when you go to like visit your commercial car suspensions. So like at certain point, the suspension won't compress. So what happens if you are having 10 coils in the like 10 individual coils in a spray. So they will keep a buffer with the 3 or 4 coils left over. So what happens if your car jumps through a certain level of height and it's dropped down? So your spring will compress, all the six will compress, but this four won't compress, so that it won't damage the damper and break through your that thing, your vehicle chassis. So the buffer is something which keeps some number of coils won't compress. It is like a safeguard thing. So it won't let completely damper get compressed and break by itself. So that is what buffer. And like majority of the vehicles won't use any buffer. Like with respect to Baha vehicles.
Um,
While entering mass of the vehicle in the vehicle data generator, we enter the
okay.
total mass initially, but after separately adding all the other masses, we ended up with an overall mass of 500 kgs in the info. So should we also add roll gauge mass in the vehicle data generator, or have I done some mistake? So basically what happens is first of all, you just measure your vehicle individual component weights. So, and as you have already tested the IPG and you have ended up with the 500 kgs. So as after this workshop, you know where exactly the weights have to be defined. So remove every weights what we have said in that individual section, and remaining weight you add in the vehicle generator like generator data set. After that, you add all these individual weights and you will get your accurate vehicle.
Okay, got it. Any more questions, teams? Sandeep, would you like to clarify this again? An error?
So this road sensor. So basically, it is what happens is when you give over your, it is a road sensor, right? So have you entered any sensors regarding with the road in your vehicle? Please just kindly reach out to me. I'm dropping my number over here.
Sandeep bro, can I tell something?
Yeah, definitely you can add.
This error comes when they didn't input the sensor while running movie in the road scenario. The sensor will follow the vehicle, right? If the vehicle goes topple or goes out of the track, the road sensor error will come. Or if you didn't enter the road sensor properly while generating the car data, this error will come. They can check if they have problem with the input sensor or while running movie. Kindly check team about this error.
Yeah, thank you, Sudarshan, for that thing. Rajendra, so the value of linear to DOF will be getting from your suspension, like multi-body simulations. So you do multi-body simulation for your suspension, so the jounce, bounce, travels, everything that reflects in this thing. As also the Siddharth has mentioned over here, you have, so you can see what are these travels, transition TX, TY, TZ. So this is the track change. We'll be saying elevation change. So once you go through this user guide and also the manual, you will get to know what exactly these all things reflects to. Okay. So with this respect to with your multi-body simulations, you get your values. So you enter the values in over here and you get
Sorry,
them. Yeah.
uh, sorry.
Yeah. No problem. No
Um,
problem.
okay. Yeah, wanted to add few more. Having a question regarding this, one DOF and two DOF. difference. What is the difference between 1DOF and 2DOF? Considering the same, like for the 2DOF, we are having an option of opposites. Whereas for the 1DOF, we are not having an option of opposites. This opposite value gives the variations of parameters. Like it is based on your camber angle. Like suppose your vehicle is moving is having a camber change with respect to the bump as well as stroke, then it should be mentioned in this opposite option. Okay. Yeah. Uh, Coming to the next. Uh, how is the 2D of rear kinematics like the TX, TY, and TZ values? Okay. For this, you need to refer the user guide once again. Um, in the user guide, we are having a option. We are having a definitions of each of them. That is a TX, TY, TZ. That is a wheel travel variations, wheel wheel center variation, track variation, and wheel travel variations, which you need to calculate based on your geometry and enter it accordingly. Come again about the opposites. Okay. This opposites you can refer to the user guides. This this means the deviation between the like suppose if you will enter a values in the translations, that is x, y, and z coordinates, which will be a very linear to the values, like a static value will be there. But in case you as per the real physical parameters, there will be a variation with respect to your travels. That is a camber angle and other angles, that is toe as well as camber. So oppose will help you to parameterize that. Like in case if you are having a variation in parameters, a ratio between the meter to meter, then it will help you out with the same. Yeah. In case if there are no further questions, we can conclude this session currently. Um, yeah. Teams, anyways, we are going to meet again tomorrow at 6:30 for the upcoming sessions on IPG kinematics. A brief introduction on kinematics. Then we will go through with the scenario editor, how a road, how the obstacles can be modeled in a scenario editor, and a few glimpses on controls as well as instruments and maneuvers. That is how you can edit your maneuvers and scenario editors for your specific vehicle test runs. Okay. Addition to that, we are also having a session on tire generation. If you are having a custom tires, where you can create your custom file representing your tire model. Uh, yeah. Thank you. Thank you, team, for joining. Thank you, Rohit, for explaining us with the games of kinematics, and thank you all.